while I write the header for our notes, I'm going to give you some bell work. So work on this while I write the header up for us. It's 1 over r is equal to 1 over 2r minus 1 over r squared. A hint: will be to determine the LCD, the least common denominator. So everyone, just write this down so that I can then write up here. Does everyone have this written down?
Yes. No, okay. I don't.
Please write this down. Okay, so before we get to today's lesson, let's solve the bell work together. So what was the LCD, or what is the LCD? It's 2r squared. So determine the LCD. It's 2r squared. So in order to get a 2r squared here, in the leftmost term's denominator, what do we need to multiply by?
2r.
A 2r. So 2r in order to get 2r squared over here, what do we need? Just an r. And Of course, here's missing a 2. And what you see is you see the multiplicative identity property being used. The multiplicative identity property. And of course now we just multiply across. And so we have 2r over 2r squared is going to be equal to r over 2r squared minus 2 over 2r squared. We need to get rid of the denominator, so we multiply everything by 2r squared. Which property is that using? It's the multiplicative inverse property. The multiplicative inverse property. And we are going to multiply everything by 2r squared. And I'm just going to go ahead and write it like this. And of course we know that this will cancel out, that cancels out, that cancels out. And then we're left with 2r is equal to r minus 2.
So why do you multiply by 2r squared?
Because we have to clear out the denominator. So r is equal to negative 2. Okay, but today's lesson is to transform quadratic functions into vertex form and graph them, highlighting properties such as axis of symmetry, intercepts, domain range, minimum and maximum. So we're going to look at number 17 from the handout. The steps are going to be the first thing we want to do is put this into vertex form. We're going to put this into vertex form. Vertex form is a times x minus h squared plus k. This is accomplished by using complete the square. we're going to add and subtract 1/2 the coefficient of b squared. We need to be able to transform this into this. This is a perfect square binomial. It's a perfect square, and it's a binomial because it contains two terms. But we have to use complete the square to get that. The first step is to use our associative property of addition. To associate together the first two terms. Then we're going to factor out a 2. This is where we will incorporate our complete the square formula. What is the coefficient of b? It's -8. So, using our formula, we have this is equal to plus or minus 16. What? It has to be 1/2 the coefficient of b squared. That's the formula for complete the square. It's got to be this. Now, did we really only add 16? Let's look at the 2 out front that we factored out earlier. If we were to multiply the 2 back through, how much did we add? What's the quantity? 32. So even though our complete the square gave us 16, we actually added into this function 32. So we have to subtract 32.
All you're doing is dividing the whole equation. Okay, I'm a little confused. Okay, so because all of those numbers can factor out by 2. Like 2, 16, and 30. 2, 16, and 30, they all can be factored out by 2, right? So why we couldn't just divide the whole equation by 2 and then have x squared minus 8x plus 8. I'm confused.
So what I would recommend is there anybody else that would like a more detailed explanation? Okay, so I would suggest if you could, I can't hold the whole class up here. Please come to intervention. So continuing on, we have 2 times x squared minus 8x minus 2. And what we're looking for now is we have to ultimately get this into this form.
Mr. Thomas, can you please show me how you got 32, please, again?
He multiplied 2 times. I got 32.
So I got 62 because we had 16, and I put 16 in, but we had factored a 2 out earlier on. And so essentially we added 32, not just 16. And so I have to subtract 32. This is the additive identity property. If we add a quantity and we subtract the same quantity, what is the result that we've added? 0. That's the additive identity property being used. I've stressed over and over again in this class, in any math class that I teach, if you can learn when to use them and how to use the 9 fundamental properties of arithmetic, you will be so good at doing math. We've already used 4 of those properties just today so far. We've used the multiplicative identity property. We've used the multiplicative inverse property. We've used the associative property of addition. And this here is the additive identity property. 4 of those 9 properties have already been used just today.
Okay, so you got 8 because you took half of the square. I mean, you took half of the square 16 and multiplied. You got 8 because you divided it by 2. How'd you get 8? Divide by 2 squared. So you always divide the middle term by 2 squared.
So we have to ultimately get this particular form here. Well, we have our K and we have our A. We need to get the X minus H. We need to get this into this. And we can do that by grouping.
They'll be X minus 4 squared.
So we have it now, and so now we can plug that back in. It's 2 times.
Okay, when you got that form, did you use the X factor thing? Did you do what can multiply to 16 and add to negative 8?
Mhm. So we have our vertex form now, yes.
You know the question, you didn't need questions off of a review sheet. Is that on camera?
Yes. Mhm. So what's our vertex? It's 4 and negative 2. Yes, exactly correct.
Can you give us a problem so we can go by ourselves? Especially that.
The next step in this problem
Okay.
let's not lose sight of what we're trying to do. We need to graph this. And so we've got the vertex, and now we need to determine what the x and y intercepts are. And so the y-intercept is determined by setting x or y to 0. X. So I plug 0 in for x. And we have 30. And so our y-intercept is going to be zero and 30. Now our x-intercept is more difficult. The x-intercept is determined by doing what? And solve for x. And so, using our function, we have 0 is equal to 2x squared minus 16x plus 30. We have a quadratic equation. It's a quadratic equation. How do we solve quadratic equations? We can always use the quadratic formula. So we need to choose a method to solve the quadratic formula. It's going to be complete the square. You can use factoring. We can use grouping, and we can use the quadratic formula. Which one do we want to do here? We can use factoring, and we can also use the quadratic formula. So let's try to factor this. So if we take 2 out, so we're going to try to factor. So 2 is not equal to 0. The zero product principle, right? The zero product principle. Since 2 is not 0, we set equal to 0. And what will be our numbers? So we have that x is equal to 5 and 3. So x is equal to 5 and 3. So we have our vertex, we have our y and x intercepts. Do we have enough information to graph this? And now we just start plotting these 4 points. And so 4 and negative 2. Zero and 30. We'll just put it up here. It's not to scale. 5 and 0. Well, if that's 4, we know 5 is just to the right of this. And 3 and 0 must be just to the left. And so now we should be able to construct our parabola. What is our axis of symmetry? The axis of symmetry. Is there symmetry to this graph? Yes. At what line? It's a vertical line. X is equal to 4. So that's the axis of symmetry. Where's our minimum point? It's 4 and negative 2. Does the graph have a maximum point? No. What's the domain for this graph? What's the input for this function? Is there, in other words, is there any restriction on what numbers x can be? There's no restriction. So if there's no restriction, the domain must be all real numbers. What's the range? Is there a restriction on our range in what our y values or our output can be or will be? Yes. And what's the restriction? From -2 to positive infinity. Okay, so while I go around and check your notes to give you guys classwork grade, I'm going to give you some exit work today. So exit work. I'm going to come around and check it. So your exit work for today . there's an attendance sheet to be passed around, so be sure to sign that attendance sheet. So the exit work, let's review this quickly. The least common denominator is going to be 3x squared. And we're going to be using which two properties? The multiplicative identity and the multiplicative inverse properties. And so what are we missing over here? A 3. So 3. And we're missing a 3x. So that's the multiplicative identity property being used. And we have 3 over is going to be equal to 6 minus over 3x squared. We can use the multiplicative inverse property to multiply 3x squared all the way through. Three is equal to x squared. So x is equal to plus or minus the square root of 3. Okay?
Students